So Unit 8 is about climate. As you remember, there is a difference in climate and weather. Climate is your average over a long period of time looking at a region, while weather is a more current, local, what's currently going on in the atmosphere right now. Now, with this unit, we're going to be using concepts that you have already learned and just piecing them together. So the way that I'm going to teach this is I'm going to help you think through things before I just give you the information. Because again, you already know all the information for this, so you could figure it out yourself if you just did a little bit of critical thinking. So what is climate? Average over a long period of time looking at the regions. And remember also there are two things that we classify climate with. We are looking at your precipitation, precip, and then also your temperature. So the temperature and the precipitation is what makes a climate. Okay, so factors that affect it. These are what we are going to look at. Latitude, elevation, topography, bodies of water, global winds, and vegetation, which you've already learned about these things. So the first factor, latitude. So what is latitude? Well, if you think back, latitude are the different lines. They're the distance north and south of the equator. So you have 0 degrees latitude, which is your equator. And the higher up you go in your latitude, further away from the equator you get, the colder it gets. So when we look at climate, we've got to remember that the zone by the equator is going to be the hottest, and the zones by the poles are going to be the coldest. And what's in between is actually in between. It's in the middle. So this is the reason why the latitudes have your different temperatures. The direct sunlight, the 90-degree angle, is at the equator, and then it's hitting at a more indirect or smaller angle, which is about 23 degrees for the poles. And that's what makes it actually colder at the poles rather than as warm as it is at the equator. So seasons are going to be based on that tilt of the Earth's axis. When the Earth is tilted, you get different seasons. And the seasons will still vary based on the latitude because of those angles. Further from the equator, the colder they are. So changes in latitude creates 3 zones. And that's because of that indirect and the direct sunlight. And I'm going to draw those zones for you here. So our first zone, which you could probably think about, let's make it red. This is what we call the tropical zone. The tropical zone is right by the equator, and it's going to be warm year-round. On either, well, then we'll go to the other one. So the tropical zone is kind of obvious, and then we have our polar zone, which is going to be, whoops, that's supposed to be by your poles, so the polar zone. And then in between that is what we call the temperate zone. So temperate. This is the temperate zone. This is the zone that's very moderate, and this is where we live. We live in the temperate zone. So the tropical zone is warm year-round. Temperate is going to have all 4 seasons, and then polar is going to be cold year-round. And this is simply because of our differences in our latitude. No matter what seasons, polar is going to have cold summers and cold winters. Tropical is going to have hot summers and hot winters. Temperate is where we get into 4 different ones, like you're already familiar with because you live in the temperate zone already. And so next we're just going to look at those actually typed out. So latitude creates the 3 zones. The first one, tropical zone, which you can see in green, that's by your equator, and it's warm year-round, and that's because it gets the most direct sunlight. Your temperate zone, that's what's in green here. Temperate zone has hot summers and cold winters. Remember, this is where we live. If we're looking at the temperate zone, I'll go back to this picture. Remember, we live about, say, this little line that I'm drawing is about where North Carolina is. That's where we are within the temperate zone. So we have hot summers and cold winters. And then your polar zone is going to be cold year-round. And again, that has to do with that very indirect light. So you already know all that stuff. We're just kind of piecing it together and putting names on those zones. We're not going to do that because you're not here. Okay, the next factor that affects climate is your elevation. So when we look at elevation, we're looking at like hills. So the higher up you go, remember, the colder that it gets. So specifically when we look at elevation, we're going to be looking at a mountain. So I want you to imagine, no, we're not, never mind. We're going to visualize the mountain on the next one. For this one, just knowing that higher up you go, the colder it gets. I don't need to draw a mountain for that. So when we look at elevation, we're looking at you increasing your height and altitude. So here is a picture of a mountain that's in Africa. And down below where the giraffes are, it's very, very warm. It's going to be very dry in that particular grassland. But as you go up that mountain, because that mountain is so high up, that it's so highly elevated, and that you're going at such a high altitude, it's going to be colder. That's why you have the snow caps. But you already know that the higher up you go, the colder it gets. So higher elevated areas, such as the tops of mountains, will be colder than the bottoms of it. One thing that you might not have realized, but again, you already had the information for, is that also the higher up you go, the more precipitation you get. And that's because, remember, when you have rising air, it gets colder. And what do we know cold air does? Well, cold air condenses. It gets really close together. So if you have all these cold air molecules condensing and squeezing together, it's going to make the air reach its dew point sooner. And if it reaches its dew point sooner, it's going to force clouds, which then gives it precipitation. So it could be very dry down where the giraffes are, but it can be very moist up at the top of the mountain where the snow is, because the cold air that's condensed, it has squeezed out those water droplets and it's created clouds and it's created dew, therefore leading to rain. So elevation, higher you go, the colder it gets, but also the more moisture you have. Topography. So remember from Unit 1, topography is simply looking at the changes in elevation of the land. So we're not looking as much as you going up in the atmosphere. We're looking at, do you have hills? Do you have mountains? Is your land really flat? And if you think back, the type of map that shows topography is your topographic map. And the lines on your topographic map, those are your contour lines. Remember, those showed you how high or how low things were. So if you think about how a mountain would affect your climate, I'm just going to explain it to you, and I'm going to draw it out. So now we're going to picture our mountain. So let's see. We have a mountain here. Now, if you are wind, the air blowing, the wind, we'll just write wind. If the wind is coming towards the mountain, it cannot go through the mountain. So what it's going to do is it's going to go up and over the mountain. Now, as that air is going up over the mountain, as it goes higher, it's going to get colder. And as it gets colder, that's going to force it to cool and condense, leading to cloud formation. And if you have cloud formation, you're going to get rain. So on this side of the mountain, we have clouds and we have rain, and it's colder. Now, the air is not just going to stop once it gets to the top of the mountain. It's got to continue to journey down the mountain. As it's moving down the mountain, if air is sinking, are you going to get any clouds? No. So over here, it's going to be very dry. It's also going to be warmer because it's not going to have any rain to help cool it off. So this side of the mountain is very dry and it's very warm because of that sinking air. Over here, it's going to be very cold, or not cold, but it's going to be cooler, and it's going to be moist because it's going to have precipitation. This side of the mountain, they sometimes consider it a desert because of how dry it can become, and that desert can go out for like 100 miles. So the side that has the wind and the rain and the clouds, this is what we call the windward side. So the side with the wind is what we call windward, and I'll change my color to red. So this is the windward. Actually, you know what? I'm going to erase this drawing, and I'm going to show you a drawing that looks a little cleaner. Okay, here's your picture that looks a little bit cleaner. So you have your mountain, and remember you have the wind that's going towards the mountain. So the side where the wind is coming from is what we call the windward side. As that air goes up and over the mountain, it will cool and condense to create clouds. The air will continue moving down the other side of the mountain, but by this point, it's already used up all of its moisture, so now the air is sinking and it's very dry. So this opposite side is what we call the leeward side. So the side with the wind is windward. The opposite side is called the leeward side. The nickname for the leeward side is the rain shadow because it's in the shadow of the rain. And it's going to be very warm and dry. It's going to be more like a desert-like condition. If you've ever seen the movie Holes, it's a very good movie. I do recommend it. It's an older movie. But at one point, the guys are digging the holes, and the new guy, Shia LaBeouf, he looks at the mountains, and he sees clouds. And the guy tells him the clouds never make it over the mountains. And where they're digging the holes, it's in the desert because they would be considered on the leeward side of the mountain. And so, again, those deserts can reach out for 100 miles. So on the windward side, you're going to have the cold, moist rain. And the leeward is going to have sinking air, just like high pressure, and it's going to be warmer and drier. And so this is just a picture. Now notice in this diagram, the windward side is on the opposite side of what I just drew. That's on purpose. Don't memorize, okay, the left side is always windward, or the right side is always, it's not like that. It's where the wind is coming from. So if the wind is coming from the left, then the left side is windward. If the wind is coming from the right, then the right side is windward. But you've got the wind that goes up over the mountains. Again, it's got precipitation, and then it drops back down, and it's the leeward side with that rain shadow. So one side is cold and moist, and that's the windward. The other side is warm and dry. Factor 4, large bodies of water. Now, this isn't just talking about like a pond. This is looking at like a large lake or even the ocean. So a large body of water, if you remember the difference in how land and water heats, which hopefully you do, land heats very quickly. So land will get very, very hot, and then it will get cold very, very quick. Water takes forever to heat up and forever to cool down. It changes temperature very slowly. So if you are living by a large body of water, and hopefully this looks familiar because this was a test question, if you are in St. Louis, you're surrounded by land. So your temperatures are going to shoot up and then they're going to shoot down, if that's the graph. In San Francisco, you're surrounded by water because you're here on the ocean. So your temperatures, it's going to take a long time for your temperatures to get warm and a long time for them to cool off. So your temperatures are staying very consistent, or what we call very moderate. While in the middle, where you have no water, you're getting very hot and then very cold. So temperatures of a large body of water will influence the air above it. So if you live, say this temperature of the water here is warm, then the air above it is going to be warm, making this land warm. We call these moderating winds. So land will change quickly, and it'll get hot, it'll get cold very quickly. But if you're by that large body of water, then you're not going to get hot very fast, you're not going to get cold very fast. You stay more moderate or more consistent. Now, one thing that I get if I ever give questions like this, and I say, what's the difference in how St. Louis and San Francisco will heat? People will say, well, San Francisco will be warmer because it's by the water. No, it's not that it's warmer, it's more consistent. Again, picture you have a graph. So if this is St. Louis, the high, say, is 90 and the low is 40. When San Francisco the graph will look more like this. So the high would be 80 and the low would be 60. So it's not that it's warmer and it's not that it's colder. It's that it's more consistent or more moderate. So make sure you do keep that difference separate. This is a fun game, but we can't play it. But maybe you can get some people together and play. Okay, global winds. This is our fifth factor, 5th out of 6. So global winds. Remember, these global winds are caused by the differences in how the earth is heated. The equator is very warm, the poles are very cold. So that's going to cause the warm air from the equator to rise up to the poles and the cold air from the poles to go down to the equator. That's what causes them. The purpose of them is to balance out the global temperatures. In the northern hemisphere, global winds move to the right because of the Coriolis effect. Remember, if I say, do you live in the northern hemisphere? You'd say, that's right. Therefore, the winds curve to the right. In the southern hemisphere, they curve to the left. And they change climate by just by balancing things out. So global winds will distribute heat and moisture around the earth. Just like I said earlier, they move warm air to the poles and cold air to the equator. And that's the same thing our ocean currents are doing. So your global winds are driven by temperature differences, and your ocean currents are driven by density differences. What causes the difference in density is either the temperature or the salt content. So just throwing in some good review there. And let's keep going. So climates determine, this is just kind of interesting, but climates will determine the vegetation that will grow. So if you have a really warm area, you're going to only grow certain types of vegetation. And if you live in a colder area, only certain types of plants will grow there. But what's interesting is vegetation can also affect temperature. So when we look at our very last factor, vegetation, your vegetation will change the temperature and it will change the moisture of an area. This first slide is showing how it changes temperature. Our next slide will show how it changes precipitation. So one of the obvious things that plants do is they're absorbing sunlight because they're absorbing it for photosynthesis. Since the plants are absorbing that sunlight, it's going to actually make the temperature of that area a little bit cooler. Also, thick vegetation, such as like a forest, is going to have a lot of shade, and that's going to cool things off as well. Plants also help reduce the greenhouse effect. The greenhouse effect is how the earth is naturally getting warmer because of carbon dioxide and things like that. But if plants are absorbing that carbon dioxide, they're removing the greenhouse effect and therefore making it cooler. So now the question is, how does it affect moisture or precipitation? So plants are going to absorb, or they're going to take up from their roots water, but remember they release some of that water into the air surrounding it through the process of transpiration. So because of that, if you have a lot of plants in an area, it's actually going to make that area more humid. Now, in my backyard, I have an oak tree, and that oak tree is a very new tree. It's not much taller than me, and it's about as thick as like your pointer finger. It's a very small, flimsy little tree. Too many birds land on it, then the tree bends over. Now, if I go stand next to that tree, it's not going to feel cooler or more humid. This is only talking about if you have like a thick vegetation, such as a forest, or if you go to the rainforest. One or two little trees in your yard, you're not going to notice this difference. So deforestation, which is cutting down all the trees, that can actually make those areas warmer and drier. So in the rainforest, they're starting to cut down a lot of trees. And this is a picture of the rainforest where some of this is occurring. And the rainforest is known for being very humid and it'll be a little bit cooler than some of the surrounding areas, and it has tons of vegetation. But now that all the trees are being cut down, they're actually getting these pockets of desert-like regions. Because again, all the vegetation, it typically makes it a little cooler and it provides more moisture. And so if you remove all of that, you get rid of that effect. And so one of these videos, or you can watch both of them, but it's just talking a little bit more about that. So if you'd like to learn more, you can. This top video for Will Smith, there's a show on Netflix you can watch, One Strange Rock, and he's the narrator for it. And it's just a clip from that show that's very interesting, talking about a flying river that talks about some of this climate stuff. But I do recommend watching that. Very interesting, fascinating to see. And also, I really like Will Smith, so he's just fun to listen to. But that is it for this video, and we will pick it back up with part 2 of Unit 9.